And we will start with Shashank. I'm hoping that Shashank is already with us. I will just introduce Shashank to you. I met Shashank several years ago when he was just graduating from NID as a product designer, ceramic artist. And a very small, brief conversation led to this friendship and this collaboration. And Shashank is actually focused on post-production ceramic waste. So in the production of ceramics, as you can imagine, there's a lot of breakage. And then a lot of that damaged material was simply going to waste. And so he had this idea that one could salvage that material and reuse it and make ceramics again from that. And so this is what his company, Earth Tattva, does. It uses 60% of post-industrial landfill ceramic rejects to make food safe and 35% stronger ceramic wares that are 100% recyclable. Path-breaking work. And so you can look up his website, earthtatva.com. And so I asked him, he was one of the first people I asked that, can you please look at what can be done with this? And it was very exciting to see what he was able to do. So Shashank, if you're ready, I will stop sharing my screen and then have you share yours.
Sure. Thank you, Manisha, for the introduction and for
welcome,
making us
Shashank.
a part of this effort.
There you go. Yeah.
I'll just pull up my presentation.
We can't hear you so well. So...
Yeah, I'll just pull up my presentation.
Yes.
Yeah. Yes. Is it visible?
Yes, it is.
Okay, great. Hi, everyone. Yes, so
the voice could be slightly louder, I feel. Is that possible?
Is this better?
Yes, that's better.
Okay, yeah. I am from Earth Tattva, and as introduced, we basically deal with ceramic waste, and that's why we were so excited to be associated with the initiative of PUNARAVARTAN, because clay is something that we are very close to as our basic material that we work with. And this is something that we often overlook as users of any kind of ceramic or clay products, that clay is reusable virtually endlessly until and unless we fire it. And that's how most of our festivals are based on, because if we make any Ganesh idol out of clay, and traditionally we definitely didn't fire it, and it was definitely not made of plaster. So that's why we could immerse it and keep reusing it every time. And we always use local clay for that. But then, of course, these days there are a lot of different materials coming up. So what we did was, the clay that we received from the immersion, we had two different kinds of clays, I think. And with that, we started making a very small test style with it. That's the basic process that we go through while testing any clay material that we procure for our production as well. Because there are a lot of different properties that we have to test with the clay, both before firing and after firing. Before firing, we have to see how plastic it is, basically how malleable it is, how easily it would crack, or how thin can we make it without cracking. And it's very important for us to slow dry the clay, whatever object we make out of it, especially when we are making murtis, because there are so many parts that we attach together, and all these attachments are the most prone to breakage or bearing cracks. So that's why it's very important to let it dry slowly. And we were very happy that the clay that we received was quite plastic. We were able to do pottery on it as well, on the wheel. So that was very exciting. And then once it is dry, we fire it at 900 degrees Celsius, so that all the water from the clay is removed from its molecular structure, and then it becomes an irreversible material. We cannot dissolve it in water again. And then at that stage, we are able to handle it better than the unfired clay, because it is more stronger. And on that, we are able to apply glaze as well. So glaze is basically a glass forming material, which makes all our ceramic tableware food safe, because glass, as we know, is one of the most inert materials. It doesn't react with its environment, and that's why we can also we usually traditionally store our pickles in these ceramic jars. So that's what we started doing as well for these tiles. And then when you see here in the lower left corner image, we have these cross marked on the tile on the back side, and we have marked it for 10 centimeters basically. And this is something for us to know how it is the shrinkage of the clay, because every clay, when it dries, whether it sun dries or it is fired, it loses moisture from it, and that's why the whole content of the clay shrinks. And whenever we design any products, we have to keep in mind what is the shrinkage of every raw material. Based on that, we have to make our products so many percentage so much times bigger, so that when they shrink after the final firing process, we get the exact dimensions of what we need in the finished product. So these were all the tests that we did. Interestingly, for this clay, we were observing these fine line cracks on the surface. We are still figuring out why we could get that. It could also be because of a couple of impurities that were there, because there were so many materials that were mixed. So that is something that we are still trying to figure out. But then in terms of its malleability, it was quite good. And then we tried applying a transparent glaze over it. So that's why we are also able to see the clay beneath it. And interestingly, when we apply this glaze on it, we see the color of the clay becoming more saturated rather than the one which does not have the glaze on it. Then we did the wheel pottery testing, where we were able to actually throw quite a tall tumbler out of it. Again, I think maybe the clay needs some processing and filtering so that there are no particles in it, and we also won't get these air bubbles while working with it. And then it was also good in terms of pulling the handle, because these handles are actually pulled from a blob of clay, depending on what shape and size we want. And then it's attached to the actual body of the tumbler manually. So this was also something that we were able to make. And so this is fired at 900 degrees Celsius. And that time we observed there was a vertical crack in this, but then most importantly on the surface, there are again these minor surface cracks. So we are still figuring out how to really figure out. And uh, one challenge with this is that with every batch, probably we might get different properties of the clay depending on where it was sourced from, and maybe what different materials were added to it, whether there were some leftovers of flowers, or maybe the paints that were used on the murtis, they might have got mixed with this clay, and it might be challenging for us to remove them completely. So maybe we can think of sculpture based applications in ceramics for these materials rather than functional tableware. But probably with further more testing, we will be able to figure out why are we getting these cracks and maybe eliminate them completely. Yeah. Manisha, these were the tests that we carried out. You want to
Yeah,
discuss
so
anything on
just
that?
I just want to point out because people might be wondering why the color is different. So the pink mugs that you're seeing here is a clay that is used in Amravati, and we had sourced idols from there, so we had this clay with us. Whereas the slide before, which is the gray colored clay, that is really the one that gets used a lot in Western Maharashtra.
Yeah.
So
Also,
thank you. Yeah.
the color changes after firing in general as well.
Okay. Okay. Great. Yeah, so this is great, Shashank. Like you said, the paint, even when we take the Visarjan at home, even when we take the clay directly from people's homes, the paint and the pigments used, it's very difficult to take that out and the flakes of the paint. So that is one challenge. But I'd also like to ask you, you have now been experimenting with 3D printing of clay, I believe.
Yes.
Yeah. So, do
Yeah.
you think this kind of a material could be applied in that kind of a technology?
Yes, we could, because it has good stickiness to it, and that is what we require for 3D printing as well. Because if it doesn't stick to the different layers that are printed, then it would just separate while drying and it will crack. But hopefully this sticks better, so we can definitely use it in 3D printing. The only thing is that we'll have to make sure there are no solid particles in it, otherwise the machine might get damaged.
And do you think it's possible to do a 3D printed Ganesh idol?
Oh yes, definitely.
So, is that something that we could explore?
Yes, yes.
Yeah, so like I said, fantastic, Shashank. Thank you for participating in this. And as I shared with all of you, these are all work in progress. So if there are any questions, you can please pose them to Shashank here. Any ideas or thoughts that come to you, we look forward to your inputs also. Just put your hands up and we'll have you unmute you and you can share. We could also come back to your questions after. We'll have some time at the end once we've seen everybody's work. So that could be the case. If there's Gayatri, is there anyone who'd like to say something?
No, nobody's
Asking yet. Okay.
asking yet. Yeah.
Great. So, Shashank, thanks.
We have got Manisha one question.
Yes.
Is there an issue with using it for food grade?
Yeah. So if we don't get these cracks and we are able, and when we apply the glaze, then it definitely becomes food safe because the glaze becomes a barrier between the clay and the food itself, and the glaze is a inert material. So as I showed the test style with the glaze, even if the clay itself has a surface crack, we are covering it with the glaze and then it becomes food safe.
Another question that comes to my mind, Shashank, since you are already working with recycled ceramics, and you know this is a question that comes across the board for all technologies of recycling, is the amount of energy involved, and of course not just the energy that's actually used in terms of heat, etc., but the energy to collect everything and then bring it back and redo the whole thing. So, from your perspective, since you're doing this professionally, do you feel that this entire effort of salvaging this material and putting it back into the supply chain is worth it, even if it is expensive and energy intensive?
Yes, definitely. So in fact, so we got our LCA done, which is the life cycle assessment, and in that it came about that the composition in which we use 60% recycled content, it is actually 22.4% less carbon emitting than the conventional ceramic process. And it keeps fluctuating depending on how much percentage of recycled content we had. Like we have one variant for pottery which contains 45% recycled content, that is 12.9% less carbon emission. And so overall for firing as well, we are able to reduce the firing temperature and yet achieve better strength in the material because it is recycled. It already has those glaze particles in that, so they fuse internally. And because as we have been discussing that it's actually a glass forming material, and we know that glass requires almost half the temperature to recycle as against making glass from fresh silica, and that's why we are also able to reduce the firing temperature. So if you see the whole cycle, then it's actually much better. And if we are able to implement this at an industrial scale, we can have some 25 to 50% up to cost saving.
Wonderful. Great. Thank you, Shashank.